Okay, the last topic of this chapter, and that topic is all about buoyancy. ये आपको 11 में फिर से आएगा, but try to understand it. थोड़ा सा initially थोड़ा सा आगे पीछे लग सकता है, but we'll try to understand buoyancy. Okay. Now I'll just tell the symptoms first of all. It's like whenever we have, if all of us must have, stepped into a swimming pool sometime. Okay. Or you say, suppose there is a sink which is filled up with water, and you try to put your hand into the water, you'll always feel as if your hand is being pushed upwards. Say, let's take another example. When you learn swimming, so you're taking that float pad leke aap swimming seekhte ho na. So if you try to push that float pad inside water, means in other language I'm trying to say, if you try to immerse something, then you always feel as if the float pad is being pushed upwards, right? Then you take an example of, say, you have a bottle of, say, empty bottle of Thumbs Up or something in a swimming pool, and you are trying to push it downwards. You'll always feel that there is a upward force. So the concept of buoyancy comes that in order to understand buoyancy, let us first understand what are the parameters which are present. So we should have a fluid, and when we talk about fluid, we'll be talking about a liquid in this case. Okay, we'll be talking about a liquid in this case, and we should also have a body. And the body, as I was saying, the body could be your palm, the body could be the float pad, the body could be a water bottle or whatever it is, and this body has to be immersed. Please understand, this immersed condition is very, very important. Immersed. And when you immerse this body, you can immerse it in two different parameters. One is partially, or you can immerse it fully. Are you understanding? So let's say that I have got water out here, and on this water I have a float pad, and this float pad I am trying to immerse. I'm trying to immerse partially or fully. या तो पूरा डुबा दीजिए उसको हाथ से, जैसे आप डुबा दोगे, you want to feel that something is actually pushing this float pad upwards, right? So at that time, we will always feel that there is an upward force. There is an upward force which is exerted from the fluid side. So this upward force, we will now use a better word. We will say upthrust. We'll say the word upthrust. Have you understood? It will experience this. So for buoyancy, we need a fluid. As of now, we will talk of only liquid. We are not talking of gas. So in this liquid, whenever a body is immersed, partially or fully, this body is going to experience, the body is going to experience an upward force or an upthrust. And this upward force or an upthrust is known as the buoyant force. Buoyant force. And this entire phenomenon is termed as buoyancy. So let us first just try to understand. We are in a river or we are in a swimming pool, and we are trying to dip something into the water. We are trying to immerse something, either partially or fully. Whenever we try to dip something in water, that thing will experience an upward force. That upward force is an upthrust, means it is acting in the 90 degree to that object. This upward force or upthrust, as experienced by the body, is known as buoyant force, and the phenomenon is known as buoyancy. So if someone asks me to define what is buoyancy, buoyancy is the phenomenon due to which an object, when immersed partially or fully in a fluid, that is liquid, experiences an upthrust in it, and that upthrust is known as the buoyant force, and the phenomenon is known as buoyancy. तो हिंदी में बोले तो buoyancy क्या phenomenon है? जब भी आप किसी आर्टिकल को किसी फ्लूइड में, लिक्विड में डुबोने की कोशिश करते हो, कितना पार्शियली या फुल्ली डुबो दो, तो आपको हमेशा उस पार्टिकल को लगेगा that body will try to get exerted upwards. It experiences an upthrust force. Now just try to think. Say suppose any body experiencing an upthrust. See why these words immersed are present. Let's say for example, सर वो नीचे खड़ा था, हमने नीचे से उसको ऐसे मार दिया, upthrust दे दिया, buoyancy. नहीं. Buoyancy होने के लिए the body must be immersed in a fluid. It's not that there is a force acting right below my leg and that's buoyancy. No. Buoyancy के लिए the body must be immersed in a fluid, partially or fully. Have you understood? And when we immerse it partially or fully, it experiences an upthrust, and that upthrust is known as buoyant force, and the phenomenon is known as buoyancy. इतना समझ में आया कि नहीं? क्योंकि ये deep dive जाएगा अभी, ठीक है? Have we understood? Now, the topics that we will understand from buoyancy is that we have to understand what is Archimedes principle, what is float, what is sink, why all these things happen. Everything is happening because of this buoyancy. ये ships क्यों float करते हैं? तो इतना आपको समझ में आया कि नहीं पहले बोलिए. Clear? No doubt about it. Okay. Can I go ahead now? Okay. Now let's go a little bit ahead and try to understand two more phenomena. Why does this buoyant force come into picture? Why does the buoyant force come into picture? So as I am now starting to teach you about buoyant force, ask yourself first of all, do you understand what is buoyant force? Yes, buoyant force is an upthrust experienced by an object when the object is being immersed in a fluid, that's a liquid, either partially or fully. इतना समझ में आया? ठीक है, चलिए. अब ये buoyant force कहाँ से पैदा होता है उसको देखने की कोशिश करते हैं. So we go back and we again design our that tumbler sort of a thing, and let's try and understand. So let's say this is my tumbler, and in this tumbler what I have done is that I have immersed an object into it. Let's say I have immersed an object into it. It's just for your understanding. This object is completely immersed. Do you agree? This is completely immersed. And so let's make the water pattern also on it. So this is completely immersed. Although the formulas are not there in your syllabus, but if you want, we can derive those also if you find interest. So now let's understand. We learned that day that pressure varies with depth, right? Pressure increases as the depth increases, right? Now on this particular object, you will have a pressure which is being created on this side. You have a pressure which is created on this side also. These two pressures will nullify each other. So there is no tension. There will be a pressure on the front side. There will be a water pressure on the back side. They will also nullify each other. But the problem is that if you see the pressure on top, if I see the pressure on top, then this pressure is dependent upon how much height or depth I have gone from the liquid level. Do you understand? And the pressure that this body will experience at the bottom surface will depend upon how much the bottom surface, how much the bottom surface is at a depth from the top surface. Don't you think that the depth that the bottom surface experiences is much more? So the pressure at the bottom surface is much more than the pressure at the top surface. Now let's say I take off all these arrows, and if you want to actually, so have you understood this thing that the side pressures will cancel each other, the top front pressure and the back pressure will cancel each other. However, there is a disbalance in the pressure on the top and the disbalance in the pressure on the top and pressure on bottom. Now let's get it a little bit more mathematical. और देखते हैं, हालांकि आपको derivation है नहीं, पर समझने की कोशिश करते हैं. Let's say you are at a distance. Let's say you are at a distance, say h from the top. Have you understood? And there is another distance from the top to the bottom. This particular column has a distance which is say x, and this distance is h. Have you understood? We have a liquid, and the density of this liquid is say rho. Rho is the density of the liquid, right? And this is my top surface. So pressure on the top surface will be equal to rho into g. We had understood this formula, rho g h, in last class. So rho g into h. This is the pressure on the top surface. How many of you have understood? How many of you have not understood? जो sides के pressure से कुछ नहीं लेना देना है. The side pressures cancel each other. The front and the bottom cancel. So the front and the back cancel each other. On the top, the pressure I am feeling is rho gh. मैं कितना depth पे हूँ? मैं h depth पे हूँ. I am at a depth of h. Agreed? The pressure at the bottom surface is given by how much? Rho into g into h plus x. Do you agree or not? Now, which pressure is more? Obviously, the bottom pressure is more. It is H plus X. So this product will be more. So the pressure, sorry, this should be written as bottom, PB. So PB is greater than PT. Have you understood this or not? So the excess pressure, which is at the bottom, pressure क्या होता है बेटा? Pressure is equal to force upon area. That excess pressure is actually contributing to that extra force which is throwing this particle upwards, which is the buoyant force. तो हम वो excess pressure निकालने की कोशिश करते हैं. So the excess pressure will be given by what? PB minus PT. Agreed? If you do PB minus PT, you get a rho GH plus a rho GX minus again a rho GH. Are we fine? Rho GH and rho GH cancels each other, which means I have got rho GX as my excess pressure, right? This is my excess pressure. Now, if I want to find out the excess force, now the excess force should be equal to what? The excess pressure into the area. And which area, beta? The area of the cross section. This is the area, this area of the cross section. Are we fine? Right. So let this area be A. Let this cross sectional area be A. It could have been a cylinder also. Can't समझ में नहीं आया बेटा बेटा. This could have been a cylindrical column also whose cross sectional area is A. Have you understood? Yes, sir. Now the excess force that is now generated will be equal to what? It will be equal to the excess pressure. These all will be just done in one shot in 11. So if you understand now, it becomes easy for you. Excess pressure multiplied by the cross-sectional area. Sir, how did you get this? This has come from this formula. Yeah, sir. Rather, I should do it in a reverse manner. From here, you have actually got this. Hannah, have you understood? Harshit, okay. Samar. So what is my excess pressure? Let's find out what is our excess pressure. Rho GX multiplied by the cross-sectional area A. Right? मैंने आपको एक चीज बताया था उस दिन. Cross-sectional area multiplied by the height always gives you what? Volume. This is the cross-sectional area A. What is the height of this column? X. So don't you think A and X are multiplying and they give you what? The volume of this. Therefore, I can write this as rho, the volume V into G. And this is known as my buoyant force. Though you don't have any calculation, but ICSE and all guys have calculation, you should also know the buoyant force is always given by the formula rho Vg. Rho Vg. What is V in this case? Remind you, the case that we understood right now, here the body is fully immersed. The body is fully immersed in liquid. Agree or not? Why I have written this? ये आगे पता चलेगा. So the volume that is qualifying for this is the entire volume of the fluid body. In this example, while I was deriving, my body was fully immersed. What is the formula that I got? Rho Vg. Rho means density of the fluid. V stands for volume of the body. Volume of the submerged portion of the body. In this case, the entire body was submerged. Are you understanding? In this case, the entire body was submerged. So V is the volume of the body. And sir, while you derived it, you were very critical that you immerse the whole body. So the V is the volume of the submerged portion of the body. And G means the acceleration due to gravity. This is my buoyant force. And force is what? Newton. Newton comes from mass into acceleration. You can actually check the unit of this, whether this is giving you Newton or not. Density is kg upon what? Meter cube. Volume is what? Meter cube. And G is what? Meter per second square. Meter cube cancels. Mass multiplied by acceleration. Yes, this is force. No doubt about that. ऐसे आप पढ़ते हैं physics. आपको कैसे पता वो force का expression है कि नहीं? Check the units, whether it is coming as force or not. Yes, it is coming as force. हाँ, फिर से explain करूँगा. कहाँ से explain करूँ? Starting से explain करूँ? मुझे कोई problem नहीं है. आप इतना मानिए that when a body is immersed in water partially or fully, don't you think the body experiences an upward force? Have you experienced that? If you put your hand inside a liquid, your hand feels the upthrust. How is that upthrust created? That is what we are trying to understand. So we have immersed a body completely. Now if you see, this body has got how many faces? 1, 2, 3, 4, 5, 6. The two front and back pressures due to water are cancelling each other. The sides are cancelling each other. But there is a disbalance on the top and bottom, because in last class we have studied, last class you were there, yes. Pressure is equal to rho GH. Pressure increases with depth. The top surface is at a less depth as compared to the bottom surface. So the bottom surface experiences more pressure as compared to the top surface. So the bottom surface pressure is more than the top, which means if I find out the difference, this is the excess pressure that is acting from the bottom side. Yes or no? Now pressure, ultimately we are trying to derive what? We are trying to derive force. But at this stage we are still with pressure. Now pressure is equated with force as pressure equal to force upon area. So this is my excess pressure, which is equal to rho gx. Have you understood? This excess pressure will give rise to an excess force. Excess pressure will give rise to an excess force. The excess force is equal to the excess pressure multiplied by the cross-sectional area. What is the excess pressure? Rho gx. What is the cross-sectional area? A. A into x is also the volume. Unable to understand this? What is the volume of a cuboid? Volume of a cuboid, length into breadth into height. Length into breadth is the cross-sectional area. Height is x. So that's volume. See, if you all don't study the previous class and don't see the video and come, this will get difficult from now. This is not grade 8. I can clearly say there was no point in me by deriving that entire equation, because what you are asking a question right now, Ananya, I'm not angry at you. This is my statement to all of you. The question this girl is asking, she is studious, she is regular. Even she is fumbling. The reason is that, again, upfront say you have not watched last class video. Tell me honestly. No. So you will not be able to understand. These are not easy stuff. While I derived last class rho GH, we had similar kind of a scenario. Now you are trying to recollect एक हफ्ते पहले की कहानी को आप याद करने की कोशिश कर रहे हो, नहीं होगा आपसे, क्योंकि that is a higher level study, and if you don't study and come, it will not help you. There we had clearly told you that I had told so many concepts about Amul Butter's packet. I had told you about cross-sectional area here. Cross-sectional area multiplied by a perpendicular length is always the volume. Width into height is the cross-sectional area A. What is cross-section? If I cut it, what do you see? You see this portion. If I cut this, you see this portion multiplied by the length. इसको एक क्यूबॉइड समझना बेटा, इसको तुम्हारे मुंह की तरफ दिखाऊंगा तो तुम्हें ये H वाला साइड नहीं दिखेगा. H. This is called the H, the pattern. That is A. That area is A. And what is this? Think that this is a T coaster. Coaster. How many coasters? X coasters. So the volume is what? Cross-sectional area into height. And I'm telling you upfront. Otherwise, I'll give up. मैं छोड़ दूंगा, फिर आपको मैं I'll do that pattern. Come here and write notes. I think that is more beneficial to you guys. Open your book and start writing notes, or I will start. You want PPT type study? I can do PPT type study, because you all are not studying. If you don't study physics, don't come to physics class. Maths you can still manage. You will not understand this. And why do you not get an interest? If I can go home after this condition and upload the video on the next same day night or maximum by tomorrow, what stops you from seeing this video? If you don't see the video and come, you will not understand. Upfront I'm saying, you will not understand. Now aapko ye sab and you are trying to now forcefully remember what you studied. Rather, you should have gone with me and said, sir, understood. So X and A will contribute to the volume, so it becomes rho Vg. आप इसको मजाक लेके पढ़ रहे हैं, रिजल्ट नहीं आएगा. अपफ्रंट मैं बोल रहा हूं. Chemistry, if you are doing a class, if you are doing a paper with me, it is your responsibility to go back home. I'm not going to spoon feed. This is not one-to-one tuition class. This is a coaching class. You study or not is none of my purview. I am honest to myself. Have I covered this to my satisfaction? Yes, I have covered this to my satisfaction. इसके बाद आप समझो नहीं समझो, I am not responsible for that. And that time, if any parent also tells me, no sir, give him worksheet, give her worksheet, she understands, just ask her, have she understood? वो काम मैं नहीं कर सकता हूँ. We are not, this is not dining table tuition class. कि बैठ के हम लोग एक दूसरे को, आपको पढ़ना पड़ेगा. Unfortunately, you all are not studying. And if you don't study, आप इसको कुछ नहीं समझेंगे. And I lose my interest. Because this is not something that you should ask. This was covered in last class. Now you may say, sir, आपको कुछ भी पूछने से आप गुस्सा हो जाते हैं. बिल्कुल गुस्सा नहीं होऊंगा. आप पूछिए सर एक्सेस प्रेशर का कॉन्सेप्ट क्या है, बिल्कुल गुस्सा. अगर ये अगर पूछ रहे हो तो मैं गुस्सा हो जाऊंगा, क्योंकि ये मैं आपको पढ़ा चुका हूं अगले पिछले क्लास में. एंड इन ग्रेड 8, don't you imagine that so many times I have explained you volume? Did I not tell you that for any symmetric shape, what is the volume? If you consider a cylinder, then cylinder's volume is what? Every cross section is a circle. Khira, pi r square, pi r square, pi r square. How many pi r square? Pi r square h. That's it. If you don't remember that, stop studying in class 9. You don't deserve to study science. Upfront मैं बोल रहा हूँ. और आप अगर सोच रहे हो कि फॉर्मूला बिठा के आपको प्रॉब्लम आएगा, भाई बहुत लकी बच्चे हो आप लोग. ऐसा नहीं आएगा. ऐसा नहीं आएगा. I'm sounding ruthless and harsh, and that's the way I will use, because मैं इसको इंटरेस्टिंग करने की कोशिश करता हूं. आप पढ़ के नहीं आते तो क्या फायदा. आगे बढ़े. This is buoyant force. I just tried to tell you what is buoyant force expression. If you ask me, is this there in CBSE grade 9? Well, not. You don't have this formula. You will be asked what is buoyant force. But if you don't understand this, then this will be a small portion. What you're getting is a small portion in one chapter called fluids. और अगर आप ये नहीं समझेंगे तो उस फ्लूइड में कुछ नहीं समझ पाएंगे उस 11 में. हाँ. So the buoyant force cancel out the acceleration of gravity. Why? What is a force? How can you relate a force and an acceleration due to gravity? A force is a parameter which is measured in Newton. An acceleration due to gravity is a parameter which is, acceleration and force are two completely. A bread cannot replace an orange, na? Force is Newton. Acceleration due to gravity is meter per second square. How can you correlate both? Are you getting? That question is arising because you are. Again, I'm saying, if you would have read these things properly, these questions will not arise. Force is quantified by two parameters, acceleration due to gravity as well as mass. And that time the force is nothing but the weight. How many of you saw the mass and weight video? Weight is equal to mass times gravity. That's why weight is a force. Clear? I feel very bad. मैं यही बोलूंगा, मुझे दुख होता है बेटा. मैं पढ़ाता हूँ पर I feel sad. ऐसे पढ़ाने का मतलब नहीं होता है. Okay. Now we will visit buoyant force from many angles. Okay. Now, right, buoyant force. Another way of perspective of seeing it. Now, when we see a body being immersed, then there are three types of scenario in which we can see how a body is immersed. Okay, one can be that my body is, this is the fluid level. Another can be, and another can be. These are the three possible criteria. When I'm saying, now you can say, why not the body is right at the surface? I said buoyancy comes into play whenever you are immersing. That immerse word is very important. अगर आप किसी liquid के surface पे सोए हुए हैं without any portion, not even 1 mm of your body inside the fluid, buoyancy does not come into play. Buoyancy will come into play only when you are getting inside the liquid, either fully or partially. So we have three scenarios. अगर हम तीनों सिनारियों को देखने की कोशिश करते हैं. This is my scenario 1, this is my scenario 2, and this is my scenario 3. Scenario 1 is fully submerged with top surface in line with liquid surface. Have you understood this? You are immersed in such a manner कि आप पानी के नीचे डूब नहीं गए हैं. बड़ा स्टाइलिश सा कंडीशन है. You are just at the water surface, लेकिन आपकी पूरी बॉडी अंदर जा चुकी है. Imagine this as a piece of a wood. the piece of wood has gone exactly below the water, right at the water surface. ठीक है? अच्छा, इसको हम बोलेंगे fully submerged, और इसको हम बोलेंगे partially submerged. Three criteria. These three criteria will give us to three more things of understanding. Basically, when we study buoyant force, I gave you the expression, but that expression actually comes from something which is known as Archimedes principle. Archimedes principle will give me exact clarification to three things. One is what is buoyant force. Second, it will give me the mathematical relation for buoyant force. Relation for buoyant force. Third, it will also talk about something called apparent weight loss. So let us go. We'll not get into Archimedes principle right now. Let us first understand these three things are what. I hope buoyant force हम जान चुके हैं, ठीक है? Mathematical relation, though we derived one, we will again revisit it. Let's see what is apparent weight loss. Now think yourself, when you are inside a swimming pool, don't you feel you get a little bit more lighter? आपको light feel होना शुरू हो जाता है ना? Swimming pool के नीचे you take one bucket of water. How many of you have an experience of pulling up bucket of water from a well? कुआं से पानी उठाए हो, मतलब गांव में करके. When the bucket of water is actually inside the water surface, at that time the bucket appears very light. As soon as the bucket comes up, in fact from the swimming pool, when you come out also, inside the swimming pool you walk like a champion, but when you come up you suddenly feel that heaviness has come. That means when you are, or you take a bucket of water and you take that bucket of water inside the swimming pool along with you and try to lift it within the swimming pool's depth, you will be very easily able to lift it. That means there is some sort of an apparent weight loss which happens when an object is submerged. Are you understanding this or not? Right? हमें हर कोई चीज पानी में डुबो देने से वो हल्का लगना शुरू हो जाता है. अब वो हल्का तो है नहीं, कुछ एक हुआ होगा, because the bucket of water is still as that heavy, but it becomes comfortable for you to lift it and you feel that it has become lighter. So that phenomenon is the apparent weight loss. Apparent, आपको एहसास हो रहा है कि वो हल्का हो गया है, पर वो हल्का है नहीं. अब जरा उस चीज को देखते हैं, इसमें वापस आएंगे, ठीक है? Let's go one step more and try to understand what is this concept of apparent weight loss. So let's say this is my liquid surface, right? And now I have an object. Which is partially submerged into this liquid, right? Let's take the two scenarios once again. Okay. I have an object which is in this manner. I have an object which is in this manner. And I have an object which is in this manner. Right? This is the most easy thing where it is completely submerged. This is submerged at the top. Now, as per physics, don't we think that there is a weight of this body which is acting from the center of gravity of this body? The weight acts in this direction. The weight here also is acting in this direction. The weight here is also acting in this direction. Are we fine with that? This is the weight. Apparent weight loss का मतलब है कि this weight is a force which is being acting downwards. There must be some force which is counterbalancing this weight to some extent that you feel कि ये हल्का होना शुरू हो गया है. You feel that or not? That force is nothing but the buoyant force. क्योंकि हम इसके जैसे ही नीचे डुबाना शुरू कर देते हैं, ये ऑब्जेक्ट हमें हल्का लगना शुरू हो जाता है. So the buoyant force is acting in an upward direction. Now, the buoyant force, let's say there's a force which is acting in upward direction. So I will just put it in this manner right now. Okay, let's say there's a force. I'm right now drawing it here, but it is not exactly at this place, but I'll come to it. The buoyant force which is actually here, I'm drawing it from. this position. If you look at the buoyant force, then the buoyant force is actually responsible for reducing that much weight. देखो ना, अगर कोई चीज नीचे आ रहा है, say you are standing on a weighing scale, right? If you stand on a weighing scale, then the weighing scale gets a reaction force. That's why your weight is getting recorded. If no reaction force is given, you put the weighing scale inside a lift and you switch on the lift and you start going down along with the weighing scale, वो read ही नहीं करेगा. नीचे जाके जब ढक करके रुकोगे ना, तब वो read करना शुरू करेगा. Because do I feel the load of this mobile phone? Do I feel the load of this mobile phone? Yes, I feel, because I'm holding it. Do I now feel the weight of this mobile phone? No, I don't feel the weight of this mobile phone. So in this case, the buoyant force always acts in the upward direction. Okay, so let's say this is my FB, this is my case of FB, this is my case of FB. This buoyant force is responsible for reducing a portion of weight of this particular object. That concept is known as apparent weight loss. Now, how much portion weight will be reduced? That we will see. Have you understood? कोई भी चीज को नीचे डुबाने से वो हल्का इसलिए होता है because उसके weight को counter balance कर देता है buoyant force. Now, another concept. As we study this, let's analyze one more concept. Only then you will understand Archimedes principle. What is the volume of a sphere? 4/3 pi r cube. Now I have a potato, aloo, and I tell you what is the volume of aloo. Can you tell me what is the volume of aloo? The volume of aloo you don't know, because aloo does not have any shape. So the best way to find out the volume of aloo is what? That you take a measuring cylinder and fill it with water. Let's fill this measuring cylinder with water, and let's say I have filled it up with 50 cc, which means 50 centimeter cube of water. And now I bring my aloo and I put that aloo inside this particular tumbler. How did the aloo go inside? The aloo has got a space. इसको यहाँ पे तो rent पे कमरा मिल गया. That means somebody must have made space for him. Who made space for him? The water made space for him. Once you put this aloo, you will find that the water level has gone up. And say the water level now has gone up, and this water level is reading something like, say it is reading 60 cc. What is the difference in volume now? 10 cc. That is the volume of the aloo. Is this thing getting inside your head? Whenever we dip something or submerge something, it will displace some liquid. Fill a bathtub completely with water and you get inside the bathtub, then splash water will come out. How much water came out? As much as the volume of your body. Are you understanding? As much as the volume of your body. Otherwise, how did this aloo find a space? The aloo found a space because water created that space and water has come up. Do you now understand if I write the word called displaced volume of fluid? Do you understand this term now based on this example? Displaced volume of fluid. Whenever we immerse any body in a fluid, that body will displace an amount of fluid which is equivalent to its own volume. In this case, please understand, mass plays no role. Very interesting. I am Jaideep Das. I have got a weight, means I have some mass. If you create an exact plastic mannequin of me, which is exactly similar to my physical parameters, jitna mera pet, utna uska pet, and it is plastic mannequin, so you can take that mannequin Jaideep like this. उसको भी जब आप इसमें डिप करोगे, उतना ही वॉल्यूम डिस्प्लेस होगा जितना मुझे डिप करने से होता है. हमारे मास से कुछ लेना देना नहीं है. So first thing, please understand, buoyant force has nothing to do with how heavy an object you are immersing or how light an object you are immersing. It has all to do with what is the volume of the object. What is the volume of the object? Look at my finger. Or how much portion of the volume of the object is getting into the water. ये कितना भारी है उससे हमको कोई लेना देना नहीं है. I'm again telling you. टेबल टेनिस का बॉल देखा है? टेबल टेनिस के बॉल का सेम शेप का आयरन का सॉलिड बॉल सेम रेडियस का बना के लाएंगे तो भी वो उतना ही वॉल्यूम डिस्प्लेस करेगा जितना टेबल टेनिस का हल्का बॉल. क्योंकि हमने एक वॉल्यूम को अंदर डिप किया है। बॉयंट फोर्स में मास कोई रोल प्ले नहीं करता है। Have we understood this? This is called displaced volume. Therefore, whenever you go and see these big ships, जो मर्चेंट नेवी या नेवी के शिप्स होते हैं ना, शिप्स का नाम ऐसे ही बोलेगा, this is frigate class ship, warrior class ship, destroyer class, which has got a displacement volume of so and so. Means when that ship gets into the water, वो इतना पानी डिस्प्लेस कर देता है, जितना ज्यादा पानी डिस्प्लेस करता है उतना बड़ा शिप है। समझ में आ रहा है? So this is called the displaced volume. Now, Archimedes principle say Archimedes does not, how did we define buoyant force? We define buoyant force in this example saying that whenever we define buoyant force like this, that whenever an object is immersed in a fluid, partially or fully, the object experiences an upthrust, which is called the buoyant force, and the phenomenon is called buoyancy. क्या आपको इस डेफिनेशन में buoyant force के मेजरमेंट के बारे में कुछ भी पता चला? कुछ भी नहीं पता चला। Archimedes यही चीज को आसान करता है। What did Archimedes do? You know, Archimedes had a bathtub in which he was actually submerged. और suddenly कुछ याद आया and he started running, and they say he ran without his clothes saying Eureka, Eureka, मुझे मिल गया। And that is Archimedes principle. अब Archimedes क्या कहता है? That this buoyant force will be equal to, very interesting. So concept is same. Whenever a body is immersed partially or fully in a liquid, the buoyant force is equal to the weight of the volume of fluid displaced by the body. बड़ा इंटरेस्टिंग हो गया। अभी देखो इसका मतलब क्या है। Let's go back to our आलू example. What is the buoyant force experienced by the आलू? Once we have immersed this aloo, it has displaced how much volume? 10 centimeter cube. Let that 10 centimeter cube volume of fluid be collected by us separately. उसको वजन करो, जो उसका weight होगा वही इस पे buoyant force लग रहा होगा। Weight of the volume of the fluid displaced by the object. That volume should also have some weight, right? और आप पूछोगे सर वो सब कैसे कनेक्ट करोगे? बड़ा आसान है। एक चीज है ना डेंसिटी, जो कि है मास पर यूनिट वॉल्यूम। हमें उस पानी का वॉल्यूम पता चल गया, और अगर पानी है तो उसका डेंसिटी भी पता है हमें, तो हमें मास पता चल गया। इसको जब हम मास को जी से मल्टीप्लाई करेंगे तो हमें उस पानी का वेट मिल जाएगा, और यही वो buoyant force है। तो अभी buoyant force needs another sort of a definition as per Archimedes principle. Archimedes says whenever an object is immersed in a fluid partially or fully, it experiences an upthrust which is known as the buoyant force, and the buoyant force is mathematically equal to the weight of the volume of the fluid displaced by the body. ठीक है? अब यहां और एक इंटरेस्टिंग कैच है। देखो, weight of the volume of the fluid. Don't you think this volume of the fluid should be equal to either of these two? Either of these two. If the body is completely immersed, question number 1 में, if it is completely immersed, CI, then this volume of fluid also is also equal to volume of body. अगर मैं पूरा पानी में डूब गया तो मैंने कितना पानी बाहर निकाला? जो मेरा वॉल्यूम है। क्लियर? अगर मैं पार्शियली इमर्स हुआ तो मैंने कितना पानी निकाला? वॉल्यूम ऑफ सबमर्ज्ड पोर्शन ऑफ बॉडी, पोर्शन ऑफ बॉडी। देखो बड़ा इंटरेस्टिंग है ये वाला केस। देखो इस केस में हाउ मच पोर्शन वेंट इनसाइड द वाटर? ओनली दिस मच वेंट इनसाइड। इतना ही तो पानी वो बाहर फेंकेगा। इतना का जो वॉल्यूम है और जितना पानी वो बाहर फेंकेगा, दोनों वॉल्यूम इक्वल होगा। इस केस में इसका पूरा वॉल्यूम और उसके मेजरमेंट का पानी विल बी इक्वल। इस केस में भी वही होगा। ओनली इन दिस केस ही इज नॉट गोइंग डाउन, he is still held, but he is completely submerged. Children, just try to see one small thing. If you dip an object fully in water, then the amount of water displaced by the mouse is equal to the volume of the mouse. I am saying how much does the mouse feel a buoyant force? Equal to the volume of the water displaced by the mouse. Case 1, mouse is completely in water. Then what is the volume of fluid? Equal to the volume of the mouse. Case 2, if the mouse is partially, let's say till its pointer it is below, then इतना का जो वॉल्यूम है उतना पानी वो बाहर निकालेगा. सीधी बात. अब जरा जो एक्सप्रेशन हमने निकाला था इस बॉयंट फोर्स के एक्सप्रेशन को देखिए. अब आपको सब क्लियर हो जाएगा. इस एग्जांपल में इज माय बॉडी कंप्लीटली इनटू द वाटर? यस. हाउ मच वॉल्यूम ऑफ वाटर डिड आई डिस्प्लेस? एग्जैक्टली इक्वल टू द वॉल्यूम ऑफ द बॉडी. Volume of the body. Volume of the body is equal to the volume of the water. Volume of the body is equal to the volume of the water. So let's say this is volume of water only. Multiplied by density of water is what? Mass of water. Multiplied by G is weight of the water. What does Archimedes principle tell you? Buoyant force is equal to weight of volume of fluid displaced. Archimedes, as per Archimedes principle, buoyant force क्या होना चाहिए? Should be equal to weight of volume of displaced water. Or not, I'm saying water, it can be the fluid also. Okay. What is weight of volume of displaced water? पहले आप volume, weight के लिए आपको क्या चाहिए? Weight के लिए आपका expression होना चाहिए mass of that water into gravity. What is mass of that water? Mass of that water is volume of that portion of water multiplied by the density of water multiplied by gravity. This is the mass portion. Have you understood? But since my body has completely gone inside, can I not write VH2O as simply as V? This is same as the volume of the body into rho into G. ये दोनों एक्सप्रेशन सेम है कि नहीं? तो हमने तो आर्किमेडिस, दिस इज नथिंग बट ग्रेड 11th डिराइवेशन ऑफ आर्किमेडिस प्रिंसिपल. दिस इज द डिराइवेशन ऑफ आर्किमेडिस. ये आप 11 में फिर करोगे. डिराइव आर्किमेडिस प्रिंसिपल एंड स्टेटेड. अब आपने आर्किमेडिस प्रिंसिपल को समझा और ये क्यों रो वीजी होता है वो भी समझा. नाउ लेट्स सी दीस टू सिनेरियोस. इन दिस केस द buoyant force will be rho Vg. In this case also rho Vg. But in this case it will be not rho Vg because पूरा तो गया ही नहीं, only the submerged part. So here also we will see what is the relation. Have we understood this? Okay, now I had drawn these figures. I go back to these figures and I say now a very simple thing is, I would say that this is a criteria of float. This is a criteria of float. ये ऑब्जेक्ट फ्लोट कर रहा है, गया नहीं. इट इज फुल्ली इमर्स्ड बट इट इज स्टिल फ्लोटिंग एट द सरफेस. दिस इज कॉल्ड सिंक. ये ऑब्जेक्ट सिंक कर गया है. इन दोनों पे ही कॉन्सेंट्रेट करते हैं थोड़ी देर के लिए. नाउ इफ यू आर फ्लोटिंग, इस ऑब्जेक्ट का कुछ तो वेट है. वेट मींस मदर अर्थ इज पुलिंग दिस ऑब्जेक्ट नीचे. आजा मेरा बेटा, नीचे आजा, नीचे आजा. पर ये नीचे नहीं जा रहा है. क्यों? क्योंकि बॉयंट फोर्स कह रहा है मैं तुम्हें नीचे जाने ही नहीं दूंगा. वासुदेव की तरह पकड़ के रखा है कृष्ण, नीचे जाने नहीं दूंगा. इस केस में आपको ये नहीं लगता है द रिलेशन शुड बी दैट द वेट इज इक्वल टू द बॉयंट फोर्स? हैव यू अंडरस्टूड? वेट इज इक्वल टू द बॉयंट फोर्स. मेनी टाइम्स वी से लेट्स फॉरगेट अबाउट फ्लोट एंड सिंक. लेट्स अंडरस्टैंड फ्लोट एंड सिंक सिंपली. कोई ऑब्जेक्ट किसी ऑब्जेक्ट पे, किसी फ्लूइड पे तभी फ्लोट करेगा जब उसकी डेंसिटी उस फ्लूइड से कम है. let's take that simple example and then we'll derive. Let's say this is a fluid and the density of this fluid is rho f and you have a body out here. The density of this body is rho b. If you want this to float on this, then rho b has to be less than rho f. This is a plain simple thing. अगर किसी बॉडी की डेंसिटी उस फ्लूइड से ज्यादा है तो उसमें डूब जाएगा. Which brings another nice observation. The planet Uranus is made up of only gases. बहुत ही light planet है, but Uranus is very big. अगर कोई हनुमान यूरेनस को ले आता लाके हमारे पिरमचेरू लेक में फेंक देता ना, यूरेनस फ्लोट करेगा, because Uranus's density is less than the density of water, though it is not possible because Uranus itself is so big. Are you understanding? This is one way of understanding the concept of float and sink. Here we are trying to attack it from Archimedes principle and buoyancy. हम इसी पे आएंगे, देखते जाओ. इस केस में this object is not going down because its downward force is being balanced by the upthrust, right? So let's see. W is equal to what, beta? FB. What is W? W is the mass of the body multiplied by G. Agreed? And the buoyant force will be given by what? Rho into the volume of the fluid displaced by it into what? Into G. The volume of the fluid displaced by it. Rho into volume of fluid displaced by it. The mass of this body is equal to the volume of the body, VB, multiplied by the density. Now, since this body has got a different density, इसका density हमने sigma ले लिया है. This is sigma, which is the density of the body, multiplied by G. I hope by now you understand this thing, that volume multiplied by density always gives me mass, because density is mass. This is equal to rho into Vf into G. Now look at the mathematical parameters. G and G cancel each other. Since you have fully gone inside, don't you think your volume and the volume of fluid displaced is same? ऐसे कंडीशन में फ्लोट होने के लिए आपका जो क्राइटेरिया बन रहा है, your density must be equal to the density of the fluid or water. How many of you understood this? मैंने क्या बोला था? फ्लोट करने के लिए डेंसिटी हमेशा हल्का होना चाहिए. हल्के में तुम ऊपर रहोगे, हल्के में तुम एकदम ऊपर रहोगे. अगर इक्वल हो जाओगे तुम पानी के नीचे चले जाओगे. How many of you have seen Titanic? In the last scene, Jack Dawson goes down and Jack Dawson just is floating, where Rose can see his dead body floating. That is this condition. Very harsh example, but he has not gone down. His density at that time is just equal to the density of the water. In that case, आप नीचे तो चले जाओगे, पर नीचे नहीं जाओगे. Is this clear? Let's take this scenario of sinking. Are we fine? मैं इसको थोड़ा छोटा करूं, नहीं तो एक और पेज करना पड़ेगा. इसको थोड़ा छोटा करते हैं, कोशिश करते हैं. If we can reduce this much of the diagram. Okay. So here. Anyways. Let's keep it here. This is a 50 cc, whatever it is. Now let's look at that scenario. आप sink कर गए हैं. If you sink में क्या हो रहा है? Your weight is now more acting than the buoyant force. Buoyant force ने आपको बचाने की कोशिश की, पर आपका वजन इतना ज्यादा है कि आप नीचे जाना शुरू कर दिए हो. तो इस सिनारियो में the weight is winning over the buoyant force. Are you agreeing to this? Right? What is your weight? Your weight is mass into gravity. What is the buoyant force? Rho Vf into G. Agreed? Now, what is your mass? Volume of your body multiplied by your density, which is say sigma, multiplied by G. This should be greater than rho Vf into G. Now, since you have completely gone inside water, your volume and this volume should be same criteria. So this volume cancels this volume, this G cancels this G, which brings us again to our interesting finding that if you want to sink, this was what? This was float at this position. If you want to sink, then your density has to be more than the density of the liquid. अगर आपकी density liquid की density से ज्यादा है, तो आप डूब जाओगे 100%. ये एक और interesting finding. Now, when you actually sink, sink means this is more than this. So this thing gives me another interesting thing, that there is a net force which is acting downwards, and that net force is W minus FB, because W is winning over FB. There's a net force. Newton's first law tells me that whenever there is a net force, there is always an acceleration. इसीलिए जब कोई सिंक करेगा वो आराम से नहीं जाएगा, बहुत फास्ट चला जाएगा. When the Titanic broke and it started to sink, it took only 4 minutes to travel 11 kilometers down the Atlantic bed. अब आपको समझ में आ रहा है? पहले जमाने में कुछ कुछ मूवीज में देखिएगा मृत्यु दंड दिया जाता था, आदमी को पानी में फेंक देते थे. So his hands and legs will be tied so that he can't swim, and they will tie 1, 2, 3 more matkas with his body. So when he's thrown, the matkas will fill water so that his net weight is always more than. जैसे ही नेट फोर्स ज्यादा हो जाएगा तो ये नीचे जब जाएगा एक्सीलरेशन के साथ जाएगा. इसीलिए जब कोई डूबना शुरू करता है ना, why do we say that if somebody gets drowned, it is very difficult, because once you get drowned, you have drowned because your net force is acting on you downwards, and every force, whenever you hear about force, there is an acceleration. So you will not go with uniform motion. आप accelerated down जाओगे. और इसका सिंपल एग्जाम्पल है, कभी कभी आप पतले शेक में अगर एक ग्रेप डाल देते हो, पतला मैंगो शेक में, और ग्रेप भारी है, द ग्रेप इज one grape is heavy, once it gets inside, it will go down very quickly because it has a net downward force. Are you understanding? Sometimes in physics we also study something called terminal velocity. At a velocity at which both forces will be equal, grape will remain suspended. एक लेवल तक जाके ग्रेप रुक जाएगा, वो भी होता है. फ्लूइड मैकेनिक्स इज वेरी इंटरेस्टिंग. पॉइंट इज आप पढ़ के नहीं आते हो ना. ये वाला सिनारियो आपको समझ में आया? इसका मतलब है जब भी कोई बॉडी फ्लोट या डूबता है, उसके मास से हमें कुछ नहीं लेना देना है, उसके वॉल्यूम से लेना देना है. नाउ द नेक्स्ट क्वेश्चन दैट अराइजेस, सर, इफ यू आर सेइंग that if my density is more than the water, I should sink. The density of iron is much more than the density of water. फिर वो शिप क्यों नहीं सिंक कर जाता है? ये भी तो एक रीजन है. आओ अब उस चीज को देखते हैं. If you look at the density, say sigma of iron is much higher than rho of water. But what do we see? ये हमारा ब्यूटीफुल सा जो शिप है ना, ये क्या करता है? ये तो फ्लोट कर रहा है. But it doesn't float that way. थोड़ा सा पानी के नीचे जाता है, ये फ्लोट करता है. It is not density of iron. Please understand, the whole concept is this will be treated as a body. हमने इसको फ्लोट करा दिया. शिप्स तो फ्लोट करता है ना. That means one thing has to be there, that sigma of the body has to be less than rho of water. भाई साहब, this तो is यूनिवर्सल ट्रूथ. इफ दिस इज नॉट फॉलोड, ये शिप पानी में डूबेगा ही डूबेगा. आप क्या करते हो ना, आपको जब इंटरव्यू में क्वेश्चन पूछेगा, वो बोलेगा सिग्मा ऑफ आयरन, दैट इज द डेंसिटी ऑफ आयरन इज मोर देन दैट. यू शुड आंसर, इट इज नॉट द आयरन दैट इज फ्लोटिंग, इट इज द शिप दैट इज फ्लोटिंग. देन दैट पर्सन विल से, हाउ डज दैट मेक अ डिफरेंस? द शिप इज मेड अप ऑफ आयरन. नो, हियर आई विल सी इट एज अ बॉडी. नाउ व्हाट इज द डेंसिटी ऑफ दिस बॉडी? द डेंसिटी ऑफ दिस बॉडी is the mass of this body divided by what? The volume of this body. My target as a ship designer is to reduce this. So what do I play? इसको बढ़ाओ. शिप का नीचे वाला पोर्शन पूरा खाली होता है. Now the hull is the back side. The bottom of the ship is a big hollow. जैसे नाव ऐसे रहता है ना, उसका नीचे वाला पोर्शन भी वैसा ही है. It's just like another boat which is upside down. So the volume is made so large that ultimately the density of the body is falling down and you are making it float. Okay, let's take one more example. Is density of aluminum more than that of water? Yes. But you take out the first, what you call dairy milk, and you take out the aluminum foil, put it on water, it is very nicely floating. Because उतने से मास को पीट के मेलिएबल करके इतना वॉल्यूम बढ़ा दिया है कि इसका डेंसिटी फॉल कर जाता है. डेंसिटी हैज टू बी मेड लेस. वी आर कैनॉट प्ले विद द डेंसिटी ऑफ आयरन. प्लीज अंडरस्टैंड, वी आर प्लेइंग विद द डेंसिटी ऑफ द बॉडी. अभी भी एक आयरन का छोटा सा बीड लेके मैं पानी में डालूंगा तो डूब जाएगा. बस उस बीड को मेलिएबल करके पिटते यू मेक अ बिग शीट आउट ऑफ इट. पॉसिबल? पानी में छोड़ दो, फ्लोट कर जाएगा. Is the concept of sink and float now getting clear to you? So we go back to Archimedes principle. I said Archimedes principle will tie me with buoyant force, which is now very clear. He says that the buoyant force is equal to weight of the volume of the fluid displaced by the body, not the weight of the submerged portion of the body, weight of the volume of the fluid. सबमर्ज, क्योंकि हमें सबमर्ज पोर्शन का जो वेट है, देखो ना, क्यों सबमर्ज पोर्शन, इसका वेट से कुछ नहीं लेना देना है. हमने प्लास्टिक का डुबोया, आयरन का डुबोया, दोनों के वेट तो अलग अलग होंगे, इसके वेट से नहीं लेना देना है. ये जो पानी डिस्प्लेस करेगा उसके वेट से लेना देना है. देन नेक्स्ट क्वेश्चन कम्स, इट हेल्प्स मी गेट अ मैथमेटिकल रिलेशन. वी सॉ दैट. थर्ड इज apparent weight. Apparent weight is the apparent loss of weight when a body is submerged. That apparent loss is felt when buoyant force starts acting in the opposite direction. Yes or no? You try to run very fast and you're going in this direction. Your progress is limited by somebody who pulls you back. So there is an apparent reduction in your speed. So the apparent weight loss is due to the buoyant force which is acting. Now there is a small thing. Buoyant force is a limited force. Limited force means don't expect the buoyant force to keep on increasing. If you are keeping the body right on top of water, is any buoyant force acting? No. As you are trying to dip the body slowly in this manner, the more you dip it, the more the buoyant force increases. But it will reach a maximum when? जब आपने पूरा डुबो दिया. क्योंकि पूरा डुबाने के what is buoyant force किसके ऊपर डिपेंड करता है? Rho Vg. Rho तो कांस्टेंट है, G कांस्टेंट है. जैसे जैसे V बढ़ रहा है, अब आप now try to put your common sense. Take a bottle of Coca-Cola, empty, and imagine you're in a swimming pool and you're trying to dip it. The more you dip, the more it is pushed upwards. The more you dip, the more it is pushed upwards. लेकिन जब आप पूरा dip कर देंगे, उसके बाद और buoyant force will not increase because now there is no more volume of fluid to be displaced. Are we understanding this? So if you go here now, in this case, is there a buoyant force acting here? Yes, there's a buoyant force. If I dip it further, buoyant force will increase. If I dip it further, then you come to this condition. That's the maximum buoyant force. If that buoyant force can manage your weight, भाई साहब आप बच के रहोगे. और अगर आपके वेट को बैलेंस नहीं कर पाया, आप डूब जाओगे. क्या मैं वहीं रहूंगा? बिल्कुल नहीं. आप एक्सीलरेशन के साथ नीचे जाओगे. Very fast you will travel. In fact, watch the documentary of Titanic before, or in that Titanic movie there is a scene where that guy, that have you all seen Titanic as a movie? Huh? Okay, there is a shot in which the lady, the survivor, the girl Rose Dawson, she's actually, the real lady is pulled up, so she comes on a helicopter and that director says it hits an iceberg and Titanic actually shears at the middle. So it actually first goes inside and then the hull pulls it, again it rises, third time again it goes, and there it detaches. And the two pieces are separated by almost 1 or 2 kilometers में separate होता है. So he explains it and that lady then says, the experience was much more horrifying than the way you explain it because she has seen it. And when it goes down very rapidly. It will go, watch these movies यार, अच्छे movies नहीं देखते हो, कितना सुंदर movie है. You have seen much more than Titanic. You see the normal version of Titanic. You have seen much more. Don't give me the story not allowed to. अभी मैं पूछूं तुम छिछोरे देखा है? हाँ देख लिया. और मैं टाइटैनिक नहीं देखा तो उसमें 10-11 गाली तो उस छिछोरे में भर के पड़ा हुआ है. और जो अच्छा मूवी देखने बोलता हूँ वो नहीं. Titanic I'm not allowed to see. As if he has not seen any contraband item ever in his screen. Wow, what a puppy face he is making. इसमें concentrate करो. So buoyant force, अब मेरा है, I have tried to explain it. You don't come up with questions because you don't go through the video. Otherwise, these are such interesting concepts that you should have so many number of questions that it should not end. If you look at this surface, ये surface में अगर हम इसकी case देखें ना, इसका case बड़ा interesting है. Just 1 minute. If you look at this case, nobody will ask you these questions in grade 9, but you should ask, sir, what is happening in this particular case? Let's see. इस case में क्या हो रहा है? Body is this much underwater, right? So let's see. And it is still floating. So when it is floating, this much portion is under the water. Let's say this is now Vs. Understood? So we will say that the weight of this body, अगर हम submerged portion of the water कैसा रहेगा? Submerged portion will be rho times Vs into G. This is the buoyant force. Because only this much portion is contributing to what? To the displaced volume. So this time I am not using Vf, I am using Vs. What is the weight of this body? The weight of this body is the entire volume of the body, multiplied by the density of the body, which I will take as, say, sigma, and multiplied by G. Now, the only interesting thing in this is these two cancel each other. Rest cancellation is not possible. Because now this is not equal to this. This is the volume of the entire body. This is the volume of the submerged body. So the expression that we hold here is Vb by Vs should be equal to rho by sigma. And this is the condition for a ship. Because ship does not just float on water. A ship goes down on water to some extent. और जब ship पानी में जाता है ना, तो ship में जब हम loading करना शुरू करते हैं, we will load the ship. So there are some lines created on this ship. These are called Plimson lines. So the captain will actually decide which course you are going and how much icebergs and others. So he will decide up to what Plimson line will we load the ship. इससे ज़्यादा हम load नहीं करेंगे. तो ship के criteria में हमारा जो mathematical relation होता है, that relation is this. Volume of the ship divided by volume of submerged portion should be equal to density of water, marine water, divided by sigma of the ship. Try to cover it. This is where I rest my talk on buoyancy. आपके कोई इसमें कोई फॉर्मूला एग्जाम्स नहीं आते हैं, कोई न्यूमेरिकल नहीं आता है, आपको इसमें से शायद कोई क्वेश्चन भी नहीं आएगा, लेकिन जब आप फ्लूइड मैकेनिक्स 11 में पढ़ेंगे, अगर आपने इसको इससे नहीं पढ़ा, आप इतना तड़पेंगे कि यू वोंट अंडरस्टैंड. बिकॉज इसके बाद देयर विल बी टॉक्स अबाउट अ स्मॉल चिया सीड हैज बीन पुट इनटू अ मैंगो शेक. उसमें टर्मिनल वेलोसिटी कॉन्सेप्ट्स आएगा. तो एनीवेज, आई एम नॉट ट्राइंग टू गेट यू अफ्रेड, so please do read it.